Ohm's law can be used to determine the electrical values in any common circuit, even though it may have a number of different loads. In order to solve such circuits, it is necessary to know if the loads are connected in series, in parallel, or in combination. When the type of circuit is determined, the proper formula may be applied, and the desired values calculated. In the illustration, the load resistances are connected in parallel. For loads in parallel, a new formula is used to calculate the total resistance of the circuit. Because there is more than one path through which current can flow, the total resistance is less than it would be if there were only one resistance path in the circuit. If all the resistances are equal, the resistance of one unit may be divided by the number of loads to find the total resistance. For example, assume that each resistance in the circuit in the illustration has a value of 24 ohms. Dividing 24 ohms by the 3 branches, the number of resistances in the parallel group is 8 ohms. The calculation is performed as follows. In step 1, finding number of resistances, RT, which is the total number of resistances, equals RI, which is the number of one resistance, divided by number of resistors. Based on this formula, RT, which is the total number or resistances, equals 1, divided by 3 resistors, which equals 3. Therefore, there are 3 resistances in the circuit. In step 2, finding total R in circuit 1, RT, which is the total number of resistances, equals 24 ohms, divided by 3, which equals 8 ohms. Therefore, the total resistances of the loads in parallel in circuit 1 is 8 ohms. Notice, the current flow in each branch can be obtained by calculating the current flow through each resistance, and then adding together each separate current, resulting in the total current. Once total current is determined, divide applied voltage by the total current, and the total resistance can be found. For example, assume that a power source of 120 volts is connected to the circuit with 120 volts applied to each resistance, and the current through each resistance is found to be 5 amps. To obtain this values, ET, which is the total voltage, equals 120 volts, divided by RT, which is the total resistance, which is 8 ohms, equals IT, which is the total amperage, equals 15 amps. The total current is 15 amps. 5 amps, plus 5 amps, plus 5 amps, equals 15 amps. For example, the total current can also be found by applying the following Ohm's law formulas. In step 1, finding amps in each resistance, IT, which is the total amperage, equals ET, which is the total voltage, is divided by RT, which is the total resistance. Based on this formula, IT, which is the total amperage, equals 120 volts, divided by 8 ohms, which equals 15 amps. In step 2, finding total amps, A, which is the amperage, equals 5 amps, multiplied by 3, which equals 15 amps. Therefore, the total amps is equal to 15 amps. In step 1, finding resistance in each circuits, R, which is the resistance, equals E, which is the voltage, is divided by I, which is the amperage. Based on this formula, R, which is the resistance, equals E, which is the voltage, is divided by I, which is the amperage. Based on this formula, R, which is the resistance, equals 120 volts, divided by 15 amps, equals 8 ohms. Therefore, the total resistance is 8 ohms. The calculation proves that the previous calculation was correct. When parallel resistances have different values, the total resistance of the circuit may be found by using the reciprocal technique. The total resistance of a parallel circuit is equal to the reciprocal of the sum of the reciprocals of the resistances. For example, the reciprocal of a number is 1 divided by the number. Assume that the reciprocal of 8 is 1/8. Two numbers are reciprocals of each other. When multiplied, their value will be 1. Using the known values in the illustration, in step 1, finding known values, R1 equals 30 ohms, R2 equals 30 ohms, and R3 equals 60 ohms. In step 2, setting up formula, 1 is divided by 1, divided by R1, plus 1, divided by R2, plus 1, divided by R3. In step 3, applying formula, 1, is divided by 1, divided by 30 ohms, plus 1, divided by 30 ohms, plus 1, divided by 60 ohms. RT, which is the total resistance, equals 1, divided by 2, divided by 60 ohms, plus 2, divided by 60 ohms, plus 1, divided by 60 ohms. Based on this formula, RT, which is the total resistance, equals 60 ohms, divided by 5, which equals 12 ohms. In step 4, finding known values, E, equals 120 volts, and R, equals 12 ohms. In step 5, setting up formula, I, which is the amperage, equals E, which is the voltage, divided by R, which is the resistance. In step 6, applying the formula, I, which the amperage, equals 120 volts, divided by 12 ohms, which equals 10 amps. Therefore, the resistance is 12 ohms, and the amperage is 10 amps.